So there are 5 different types of chemical reactions you're going to learn about in this class. We have synthesis, which is sometimes referred to as combination reactions, decomposition reactions, single replacement, or sometimes referred to as single displacement, double replacement, sometimes referred to as double displacement, and combustion reactions. So when I classify a type of reaction, you should know what the reactants and the products are and how many you have of each. And it really does help if you try to think about the definition of each of the types of reactions. For example, the word synthesis means to make. And basically what you're doing with synthesis reactions is you are starting off with 2 or more reactants. This example just has 2, but you can have more than 2 reactants. And you combine all of the reactants together to form one product. That is your deciding factor. If you see one product, you know it's a synthesis or a combination reaction. Here is an example using chemical substances and chemical formulas. We have 2 moles of sodium being added to chlorine gas to form 2 moles of sodium chloride. Now, just FYI, these coefficients really don't change the type of reaction. We're really just looking at the number of reactants and products in the actual equation. Here's a funny little cartoon to give you an analogy to a synthesis reaction. Just imagine 2 singles synthesizing a relationship. This is like your 2 single reactants forming one product. Here's a little animation to show you 2 substances, 2 reactants. They can be elements, they can be compounds, they can be a mix of either one, but in the end, they form one compound or one product. A decomposition reaction is the complete opposite of a synthesis or a combination reaction. If you know anything about the word decompose, you know that decompose means to break down. So what you're looking for is one reactant. If we take that one reactant and we see multiple products, multiple things on the right side come out of that, we know it's a decomposition reaction. Here is a couple. This is our reactant to start, and then this relationship decomposes into singles, and we just took this one reactant and broke it down into pieces. This is an example for the decomposition reaction, and it's the exact opposite of the the synthesis reaction. We start off with one reactant, and we break it down into multiple products. So synthesis and decomposition reactions are just opposites of each other. Single replacement reactions can be identified by looking for an element plus a compound forming another element and a compound. And keep in mind these 2 things can be flip-flopped as well as the reactants. They can also be flip-flopped. So here's the general form of a single replacement reaction. You start off with an element A representing the element, BX representing a compound, and what's going to happen here is A is actually going to try to kick B out of that compound. So when that happens, B gets out of the way, ends up being by itself, and A gets now paired up with X. So a single replacement or a single displacement reaction tells us that 2 elements are switching places. So one is displacing another. In this example, this cartoon example, we have element A coming in and taking B's spot in this little dance here, and B is now all by itself, and A is now paired up with C. So that's an example of a single replacement. Aluminum plus iron 3 oxide. When I look at these words, what I know is going to happen is aluminum and iron 3 ion are going to switch places. You'll get more into this in the next video, but just so you can see what happens with the actual elements in their formulas, here is aluminum. It's being added to iron 3 oxide, and when aluminum comes in and takes the place of iron 3, we have iron all by itself, and then aluminum making a formula with oxygen. So for single replacement reactions, you have to actually consider something called the activity series. The activity series can be found on the back of your periodic tables in our class, and I'll talk more about this in the next video. The next type of reaction is what we call a double replacement or a double displacement reaction. This is when you have a format of a compound plus a compound yielding another compound and another compound. These are going to be compounds that are exchanging their cations. And sometimes it's worth knowing that water a lot of times can be written as HOH. The reason why we like to represent water as HOH is because water is actually formed from the ion, the cation of hydrogen, and the anion of hydroxide, not hydrogen and oxide, the way that H2O sometimes makes us believe. So here's a general form of a double replacement reaction, AX plus BY. A and B are going to switch places. Then we end up with AY plus BX. Now, one of the things I want you to take close notice of is I didn't call the second product XB. Even though X comes from the first compound and B comes from the second compound, we have to put B in the front of the formula because it's in the front of the formula when it's combined with Y. A and B are representing the cations or the positively charged ions in an ionic compound. X and Y are representing the anions. Here is that general format you want to watch out for. Compound plus compound yields a compound plus compound. Here is your little cartoon, A and B meet C and D. Notice they don't look very happy with each other currently. It's kind of like a do-si-do, and when they do switch partners, they are much, much happier. And that's what happens in a double replacement reaction. So a precipitation reaction is a subset of a double replacement reaction, and a precipitation reaction is something you might have to actually identify. When you identify a precipitation reaction, you have to think about the rules you learned on the first video, at the very end of the first video, over solubility rules. So let's say I gave you this example. If I gave you this example and I asked you, is this a precipitation reaction? This is how you would attack this problem. You would first notice that the two reactants are liquids. They are aqueous solutions, and when you mix them together, you form two products. One of these products would be a solid in solution if it was indeed a precipitation reaction. So here's what you would do. You refer back to the solubility rules on the back, these solubility rules on the back of your periodic table, and you look for the anion in the list. So barium sulfate is what we're looking for. We're really looking for sulfate on this list, and sulfate is located on the bottom. At first glance, sulfate looks like a soluble substance, but we always have to check the exceptions. Since barium is listed as an exception, this barium sulfate compound is not going to be soluble. It's actually going to be the complete opposite, and it's going to be insoluble, not soluble. And so we would assign the state of matter as an S, because S indicates it's a solid, S indicates it will not dissolve in water. We now need to check for the state of matter for copper 2 nitrate. I look for nitrate on the list, which is right here. Luckily, it has no exception, so I don't have to really think too hard. And anything with nitrate is soluble, so let's go ahead and give this an AQ to represent aqueous. And aqueous means it will dissolve in water. Think of aqueous as being like aqua, and if it's aqua, it's aqueous, and it will dissolve in water. So what does this all mean? This means I am now observing a precipitation reaction. This solid product that was formed by two liquids is what we call a precipitate. And just imagine, you mix two liquids together and all of a sudden you see like this cloudy, opaque stuff inside of your solution, and that is what we call a precipitate. If you want more information about a precipitate, you can watch that first video again. Here is another example of a precipitation reaction, or a reaction that we're trying to determine as a precipitation reaction. I have lithium iodide being added to silver nitrate. They're both aqueous, so there's a potential here of a precipitation reaction. I know it is a precipitation reaction if one of these products is a solid in solution. So we're going to check our solubility rules for lithium nitrate, and really we need to look at the anion part, and an anion is a negative ion. It's the back end of a ionic compound. Nitrate's right over here without any exception, so all nitrate compounds are soluble, so we will say this is aqueous. Now we need to find iodide on our list. Iodide is located right over here, and we need to look at the exceptions to see if silver is listed, and silver is listed. So even though generally iodides are soluble, because silver is an exception, it is insoluble. This is a solid in solution. This is our precipitate. This indeed now makes this whole entire reaction a precipitation reaction. When you mix these two liquids together, silver iodide actually forms a precipitate, which is like a cloudy, opaque colored liquid, or solid rather, inside of a liquid. The last type of reaction we're going to talk about is a combustion reaction. A combustion reaction is whenever a substance combines with oxygen and it releases a large amount of energy in the form of light or heat. Now on the reactant side, we're looking for something called a hydrocarbon, and just as the word says or suggests, it's a compound that contains carbons and hydrogens. Sometimes we have an oxygenated hydrocarbon and it has an oxygen located in it, but there's always three factors about a combustion reaction that you can always look out for. Combustion reactions always produce carbon dioxide and water. So I said there were three factors you're always looking out for, and here are the three. You could almost circle this in your notes and write that combustion reactions always are plus O2, arrow, CO2 plus H2O. But these two things can be flip-flop. Doesn't really matter what order you put those in. So this is that hydrocarbon I'm talking about. And I have the O in gray because the oxygen doesn't always need to be present. So this is our hydrocarbon plus oxygen yields carbon dioxide and water always in a combustion reaction. Here is a real example of a combustion reaction of propane. So if you think about what propane is, it's the stuff that we grill with on our outdoor grills. And if I told you to write a combustion reaction, all you would need to know is there's my hydrocarbon, and the three other things stay exactly the same all the time. Plus O2 yields carbon dioxide and water. Now keep in mind these have all been skeleton equations. I have not shown you balanced equations, or maybe I have, but by accident. And we will go through balancing equations in some later videos, but this is just the skeleton equation, which is an unbalanced equation.